In this video, we'll be looking at an optimization calculus word problem. And so what is an optimization problem? Well, basically, at the very end of this problem, you're going to see something like find the maximum area of the field. If you see a calculus problem that's asking about a maximum or a minimum, this is probably going to be a calculus optimization problem. So how do we tackle it? Well, the best way for me to show you how to tackle it is to actually go through this example with you. But before we start, the one thing that's super important to remember as we're doing this problem is that the derivative or the slope is always equal to 0 at maximum and minimum points. So I'll write that down because it's super important. At max and min points, the derivative is always equal to 0. And this is, again, the most important thing to remember in this question. Okay, so now that we have that in the back of our minds, we can start this problem. Okay, so the calculus takes a while to come in. For now, this is just a regular old algebra question. So a farmer wishes to enclose a rectangular field using an existing fence. So the existing fence is right here. It's already there for one of the 4 sides. Write an expression in terms of x and y that shows the total length of the new fence. Well, the new fence, I'll highlight in red. The new fence is what I'm showing you right now, highlighted in red. We already know that this side is x, this side is y, and since it's a rectangular fence, then we should know that this is also x. So in terms of x and y, which means our answer will have x's, y's, and numbers in it, perhaps. In terms of x and y, the length of the new fence is x plus y. And we could simplify that expression by joining our like terms. So the length of our fence is 2x plus y. Now, let's put that in there so we remember and we can use it later. All right, so the farmer has enough materials for 2,500 meters of new fence. So they want us to show that y is equal to 2,500 minus 2x. Well, here's the thing. For the show that questions that say show that, they're telling you the answer. So I'm going to write the answer at the bottom of the page. They're telling you the answer that you're trying to get to is 2,500 minus 2x. And they want you to work towards that answer. So they've told you that we have 2,500 meters for our new fence. And we also know that this is our expression in terms of x and y for the length of the fence, which basically means that this value is supposed to be the same as this value. So we can make that equal 2x plus y, which is the length of the new fence in terms of x and y, is equal to 2,500, which is the length of the new fence, which we've been told. Now, we know that our answer is y equals 2,500 minus 2x. So we're trying to get to that point, 2,500 minus 2x. We're trying to take this equation and get to this equation. So it looks like we need to isolate the y because in our answer, the y is isolated. So in order to isolate the y, we would have to take 2x from each side. And we get that y is equal to 2,500 minus 2x. It was actually only one step to get to our answer. So we've now shown that y equals 2,500 minus 2x. Let's see what the next step is. Okay, so we're ready to move on to part C. You may recall from our previous slide that y was equal to 2500 minus 2x. You may also recall that the diagram that we had was x, x, and y. Alright, so now we're being asked to show that the area of our fence is 2500x minus 2x squared. Again, since that's a show that question, we know that we want an ultimate answer of whatever they're asking us to show. So our ultimate answer will be 2500x minus 2x squared. And they're basically asking us, how do we get from this point down to this point? Well, we know that area of a rectangle, the area of a rectangle, the formula for that is length times width, or base times height. We know that the length of a rectangle is x, and the width of a rectangle is y, or vice versa. It doesn't really matter if we say yx or xy. Now, again, we're working towards getting our equation to look like this. And you may notice that there are only x's in this expression. But there's a y in this expression. However, we do have the knowledge that y is also equal to 2500 minus 2x. So perhaps I can take this and substitute it in for y, which would mean that area is equal to x, which we already had there. It lines up, as you can see, x, times y, but we know that y is 2500 minus 2x. Starting to look similar. So we now see that this expression is almost looking like this expression. Let's distribute and see what we get. When we distribute, so we're multiplying x by 2500, we get 2500x minus, and we're now multiplying x by 2x, and we get 2x squared. And as you can see, our answer is the same as the answer that we're searching for. So we've shown what we're looking for. That area is 2500x minus 2x squared. And we're done with that part of the question. So that's what C1 looks like. Let's move on to C2. Okay, so now we're being asked to find the derivative of the area expression that we just showed. So we are being told that AX is equal to 2500 minus, that's 2500x minus 2x squared. And we're being asked to find A prime of x. So we're looking at question 2. That's just the derivative. So we're differentiating. And you may recall that in order to differentiate, we have 2 steps. We have to multiply our exponent by our coefficient to get our new coefficient. So our new coefficient is 2500. It's the same, actually. And we're subtracting 1 from our exponent to get the new exponent. So our x just ends up going away. And we do the same to this term. We're multiplying our exponent by our coefficient to get our new coefficient. So we have a 4x. Then we're subtracting 1 from our exponent to get our new exponent. So our new exponent is just 1, which we don't have to write. So we've differentiated our area. And that's our new expression, or A prime of x expression. Now it says, hence or otherwise, find the value of x that produces the maximum area of the field. Now when we started, I said the most important thing that you'll have to remember in this question Let's see if you remember. Think about it for a second. If you said that the most important thing is at max and min points, or slope or derivative or a prime of x is 0, if that's what you said, then you are correct. So at max and min points, a prime of x, so the derivative that you just found is 0. Super important to remember this fact in order to complete this question. So we know that or a prime of x expression is here. And we know that at the max point, a prime of x is 0, which means that 2500 minus 4x is equal to 0 at our max and min point. So now we can figure out what value of x produces the maximum area of the field by solving this simple equation. So let's do it. We can bring our 4x over, and we get that 2500 is equal to 4x. Then we can divide both sides by 4 to isolate our x, and we get that x is equal to 625. Great. So what is that 625? Well, that is the x value. Remember, our original diagram looked like this. X here, and y here. That is the x value that produces the maximum area for our field. So that value will maximize how big our field is. So x, we can actually put it onto our diagram, is 625 meters. Great. Now we're able to finish up this question. Now they want to know what the maximum area of the field actually is. Well, we know, according to this equation right here that I'm circling, that the relationship between area and x is 2500x minus 2x squared. That's one way to think about this question. So in order to do part 4, so let's label this part 3 here so we don't get lost on our page. So in order to do part 4, one of the ways in which we could do it would just be to go back to our area equation. And since we know area is 2500x minus 2x squared, we can plug in our x value, which we just got as 625, to figure out what the maximum area of our field would be. 2 times 625 squared. So now we can see that our maximum area would be equal to, when we work that out, 781,250 meters squared. And that's the end of our question.